one of our highest priorities is to move neuroscience from the lab, from the well-controlled lab, and start to see whether, the knowledge and the frameworks that we have about how the mind and brain work still apply under real-world context. And in the case of these high-stakes decision-making, it was very unclear, but yet we are starting to have the kinds of tool sets to be able to bring those studies out of the lab and measure, people's brain activity while they're doing real activity. And in groups of people like trauma surgery and special operations military, and all those people that are in mission critical environments all the time, and begin to draw the sort of necessary data and analytics to really investigate that.
Hi, folks. I'm Dan Dworkis, and this is the Emergency Mind Podcast, a space where we bring together lessons from the emergency department and beyond about performance when it matters the most and applying knowledge under pressure. Okay, this episode is epic. Our guest is Dr. Elizabeth, aka Zab Johnson. Zab is brilliant, and honestly, I'm just really excited to get to share this episode with y'all. Zab is the Executive Director and Senior Fellow of the Wharton Neuroscience Initiative at the University of Pennsylvania. Her research there focuses on vision and visual behavior. She's worked with groups like the U.S. Military Special Operations Forces and the FBI to improve their visual training and assessments. She describes herself as being passionate about how neuroscience can impact and improve many aspects of how we make choices, how we lead organizations, and how we live our lives. We go deep into the neuroscience of decision-making on this episode. Now, often in the Emergency Mind podcast, we focus on the software side of performance, but in this episode, we are into the hardware you are currently carrying around in your skull. We look at models of how the human brain makes a decision, how stress plays into decision-making, and at the all-important speed-accuracy trade-off that we are basically doing all of the time. Before we get started, a quick reminder. If you want to join individuals and teams around the world who are working to perform better during times of crisis and emergency, there are so many ways to get involved with the Emergency Mind Project community, and we would love to have you. The easiest way to jump in is to sign up for our free newsletter. It's called Knowledge Under Pressure, and you can find it at emergencymind.com/signup. This episode is brought to you in part by the folks at EM Coach, which is much more than just an emergency medicine board review program. Now, I've used EM Coach personally to study emergency medicine, and I've seen my residents really leverage it as well. Whether you are a student or an instructor, EM Coach has a lot to offer you with a huge question bank, great on-demand lectures, and a really active textbook feature. You can also use it to build out specific assignments and track learning progress with your group or your team. If you work in emergency medicine, you should definitely check EM Coach out for your learning needs. You can find them at emcoach.org. That's emcoach.org. And for the Emergency Mind Project community, they are offering a substantial discount if you use the code EmergencyMind at checkout. That's EMERGENCYMIND, Emergency Mind, all one word. So check them out, use the code, get a discount, and enjoy it. Okay, all that said, let's jump into this absolutely awesome episode with Dr. Zab Johnson. In case you can't tell, I am really excited about it. I hope you learn a lot, and I hope you enjoy. Zab, thank you so much for coming on the podcast. It is wonderful to see you again, even if over a computer screen. And I am just so psyched to talk to you about this and for folks in the Emergency Mind Project world to get even a small hint of how awesome you are.
Glad to be here.
For folks that don't know you, can you give everybody just like a 20,000 foot view of who you are?
Sure, I'll give that a try. So my full name is Elizabeth Johnson. I go by the nickname Zab because it's the middle three letters of Elizabeth. It's a nickname that I came to in college when I was really desperately trying to become an Elizabeth on purpose, but there was a tremendous amount of pushback nicknaming. So I always like to point that out because people it's not necessarily obvious to where that comes from. I've grown rather fond of it because I have a pretty generic first and last name. And so any way that's sort of a mnemonic to help people remember me is helpful so that they don't have to go through their mental memory stores to figure out which Elizabeth Johnson they're talking to. There's really only one Zab. That's really helpful. I am currently the Executive Director and Senior Fellow with the Wharton Neuroscience Initiative. My PhD is in visual neuroscience. I think a lot about how we take in visual information, make meaning from it, and create knowledge and action from the information that we see. That's my area of research specifically, but I also run this center that's now at the Wharton School, which is really interesting at the University of Pennsylvania to really bring together knowledge from neuroscience in the pursuit of trying to answer and help and assist and make breakthroughs in lots of different areas of business and really it's society at large. So I spend a lot of my time thinking about how we can take core laboratory-based knowledge and begin to really try to test it out in the wild, out in the real world, and draw the right conclusions with what it can or cannot answer. It's really a delightful and fun journey that I've been on. And I don't know what else to say about myself. I mean, a lot of different portions of me, because I'm a visual neuroscientist, I actually think a lot about art and how artwork can tell us both how the brain works, but also can tell us really interesting things about how we make assumptions about the world is around us all the time too.
Absolutely love it. So we first met in the context of Mission Critical Team Institute when we were both working with various groups of people that have to make really high pressure decisions very quickly with limited information, where the risk reward both involves a lot of real extremes, right? There's a lot of risk and a lot of like real consequences of these types of decisions. And we took very different angles in them, but we were both there talking about sort of how to make decisions under pressure better and more intelligently. I was so struck from that first meeting about the approach that you're taking to it, which, as you're saying, really involves taking sort of the core science, sometimes lab science, sometimes behavioral science, neurology and neuroscience, and mapping that into these ultra gritty, ultra real world application. How did you get started in that? What was the arc from lab science to, making decisions under extreme pressure where you and I sort of find ourselves together?
Yeah, that's a great question. I mean, I think it was through connections of people in the very beginning. So I had first actually come to the University of Pennsylvania. I had been at Duke University before then, and sort of newly trying to find my way around a business school, which was a whole new environment. And I met Preston Klein, who was also here as a colleague. And he and I had a sit down, and he told me about his ideas around making decisions under 300 seconds or less. And of course, what we're trying to do a lot of times, with the brain is to make an optimized decision making. So already I was intrigued. He already sort of was a believer in the neuroscience. He in fact got a certificate in, social cognitive affective neuroscience while he was getting his doctorate in education. So he was already a believer. I was really curious about what neuroscience might have to say around decision making. And I was really intrigued by this notion of rapid, high stakes decision making, because that's an area where traditional cognitive neuroscience hasn't been able to do a lot of work, because you can't simulate those kinds of environments very well. And if you could, it would probably be unethical, right? So you can't make people think that someone is going to die, or they're going to lose their entire retirement, portfolio. Like these things that we think of as classic high stakes environments and decisions are things that really are very different from traditional lab-based experimentation for that reason. And like I said, one of our highest priorities is to move neuroscience from the lab, from the well-controlled lab, and start to see whether, the knowledge and the frameworks that we have about how the mind and brain work still apply under real-world context. And in the case of these high-stakes decision-making, it was very unclear, but yet we are starting to have the kinds of tool sets to be able to bring those studies out of the lab and measure, people's brain activity while they're doing real activities. And in groups of people like trauma surgery and special operations military, and all those people that are in mission critical environments all the time, and begin to draw the sort of necessary data and analytics to really investigate that. So that's really where it all got started.
It's worth highlighting, I think, something that you said in that context, which is that how we learn about how the brain works tends to be in controlled environments, right? That's where we tend to do science. The more controlled, the better. In some sense, we're able to sort of map out really subtle and finely grained hypotheses and test them. But the way we operate is in a very different space. And so it's challenging to answer the question of what do we know about how the brain works in these high stress environments? In part because we don't usually look there. But the underlying assumption is that, it might not actually be the same, right? It might not be the same as how the brain works in a lab. Am I reading that right?
That's absolutely correct. There are lots of great reasons why a well-controlled laboratory study is essential, because otherwise you have too many variables, right? And you don't know what's your dependencies, what's independent, and what might be interfering. The problem, though, as you just said, is that, it may not translate into what you hope is that it gives you some, sort of ground truth so that you can start to probe. Now, when the data is messier, when the environment is messier, when you have less control over all of the context that you're manipulating, do the basic principles still operate? And that's really, in large part, what we're angling to try to do, using as many tools as we can, and sometimes with redundancy in order to know that for sure. So there's sort of a place, I think, for both of these things, and they actually have to synergize and work together. So if we get different results from the messier world, real world, then that might actually help us go back to the well-controlled laboratory and probe those kinds of questions again in a more limited context. But stress is for sure really hard, right? Like, what the experimental paradigm is to apply stress in in an ethically IRB protocol. It's putting people's hands into ice water. It's making them give a speech on to what they perceive as a panel of experts. These are the kinds of laboratory exercises that we're allowed to do, to mimic the all of the physiological response to stress. So those are quite different, I think, from the kind of stressful environments that we talk about out in the world, and especially with really, peak performing and mission critical team operators. And we also know that there's a great deal of heterogeneity, right? There are lots of people that do really incredible things that don't find those things stressful, and a learning curve around that as well. So when we get a mostly student undergraduate population to dip their hands into ice water, it might not be at all like the experts.
Yeah, to have some context around it through that. So one of the pillars of thought at the Emergency Mind Project is that most teams that operate in times of emergency aren't always in that space, right? You go in and out of that space. Preston, our mutual friend, calls it the extraordinary world. We tend to call it sort of the emergency space or whatever. And so you're operating under conditions which are maybe not what an average person would call normal. They're still quite stressful, but they're not these like ultra stressful, high stakes moments of crisis. And then you dip in and out of that crisis world as you keep going. And what we're seeing is that we have the ability in the lab to learn things about how the brain processes, use the word optimizing decision making. Like, we're trying to do the best that we can to make decisions in uncertain environments. And we're learning about that in sort of these lower stakes, quasi-stressful conditions. And then we're trying to map that into this other stuff that is just chaos in one form or another. But so maybe let's start with what we do know. It's possible that this question I'm going to ask is like way too big to approach, in which case we'll dissect it a little bit. But what do we know from a neuroscience perspective about how the brain makes decisions under these medium stressful conditions?
Yeah, I mean, I think let's even go back a step further, which is sort of how does the brain make decisions, and then add in whatever amount of stress, what that might do, just because I think that'll give us a framework. So decision making, doesn't happen in one area of the brain. It, in fact, seems to reside almost everywhere. There's sort of decision making activity when you measure responses from almost every portion of the brain. There's not like one area in particular. So that's one thing to keep in mind. And really sort of this notion of how we could think about decision making was drawn actually from my field, which is resolving perceptual ambiguity. And then it was moved in laboratory studies to areas that were sort of outside of perception, other kinds of decision making frameworks. And so that began with sort of deciding between two uncertain answers, like perceptually with an animal or a human being presented with something that might, for example, have a bunch of random dots moving in different directions, but a slight proportion of them were moving more coherently in one direction. So you can go from a framework where all of those random dots are moving 100% say to the right, that's a very easy perceptual decision. And animals and humans will all agree that those dots are moving. But as you begin to sort of decoherent some of those, there becomes more ambiguity, more uncertainty. And it takes longer for people to sort of to come to what they think is the correct answer. And so what's interesting is that you can actually computationally model that kind of process. And, to get into the weeds, this has been best modeled by something called a drift diffusion model for reasons we won't go into. But basically what it means is that there is a threshold where you would decide mostly between, let's just talk about a simple case, two different choices. Are dots moving to the right or are they moving to the left? And so now you have two thresholds. One demarks the rightward answer, one that's the left. And those are certain distance in the neural landscape, in the mental processing away from each other. If you have a lot of experience, that also sets you somewhere. So you have preferences, or what we also call bias, which is that your knowledge about the world sets you to start closer or further from one of those thresholds, one of those boundaries. And that's what we call the bias point. And then in between, there's this period of time, just time, where you accumulate evidence, and it either pushes you towards one boundary or the other. In those contexts where it's very clear that there's, what you perceive is 100% correct, you can both start at your bias point very high, close to that right, the rightward direction. But it won't take you very long to accumulate evidence. And so you can make that decision very rapidly. As you make that, harder and harder and more uncertain, it takes more time, and you might lean on one of those things or the other, like your knowledge and your framework around what your expectations are, or your reliance on something.
So we're talking here about, although this sounds really complex, what is relatively a straightforward experimental setup to test how long it takes me or somebody to make a decision about where dots are going. We're talking about how I might have a preference. Maybe I had seen 100 examples where all the dots are moving right. So I sort of have this preloaded idea, it's probably going to be right. And then now you show me a thing, and it takes me a certain amount of time based on how strong of a signal we're looking at, one sense or another, to decide, actually it's left this time.
Yeah. So you can actually, pull out of that lots of different things. So this is one of the reasons why, sometimes in decision making, there's what's called a speed accuracy trade-off. So if you're very fast, you are more likely to be less accurate in your decisions, right? And now remember that your knowledge and your experience might actually equip you. Like we talk about bias always as if it's something negative. But in some contexts, that starting point actually can be very helpful, which is why people that learn, people that are knowledgeable and experts are, have a different starting position. Sometimes that interferes, when you have to do out of the box thinking or decision making, those biases can be very detrimental to your ability to get your job done. It's harder to pull yourself away from that framework. That's another thing. But if you're slow, right, in that process, you're more likely to be accurate, but it's, you have to give up time, right? And so your accumulation of evidence going to take a really long time for you to feel, and you might be more confident in your, in your decision, but in the real world, you may have to make a decision much more quickly than your confidence tells you to. That sort of murky middle land. And it depends on the task. So that's a model. That's the way that decision scientists have thought about decision making. It sort of was drawn from my field and this idea of perception, and resolution ported over into other contexts of decision making. But it turns out that that's also the way that the brain does it. So neurons actually can be modeled using the same approach, especially with like binary or tertiary, choices between two or three things. When there are many, many more choices, it gets a lot messier. You can't build a great model for it. So that's one way of thinking about it. Now, if you add stress to the equation, So you can think about all the action that stress could do in this context, right? So one thing that stress is great for is making you more attentive, right? It ups your arousal levels, your wakefulness levels, so that you're open to taking in much more information from the world around you, right? That is what alertness does. So that's a positive aspect of at least momentary stress. Let's talk about that because of course stress can be decomposed in lots of different ways. Chronic stress is different. You cannot be alert and chronically. And so we could talk about that in perspective of medicine. That's fascinating. But momentary stress, makes you take in more information. In fact, your pupils dilate in response to that. That is your brain's way of, piping in epinephrine, adrenaline to make you actually take in more of your visual sensory environment around you. So your pupil dilation is a sign of both stress, but also a sign that you're actually trying to take in all that information and be able to be set to make maybe faster decisions. It's pretty cool, that perspective.
Yeah. And it's so interesting because we're really operating this is a gross oversimplification, so I'm sorry, but we're really operating at this sort of like the hardware software interface here, right? Some of the stuff that we're talking about decision making that we're getting into is going to be software sort of stuff. How do you think about things differently? How do you train yourself to do stuff differently? And some of it is more baked in hardware style things where, look, I feel stressed, my body dumps epinephrine, my pupils dilate, the field of my vision changes, and that's actually going to change the way that I experience and interact with the world around me. If you are hearing this and you operate in along the worlds that people do, who listen to the Emergency Mind podcast, you know viscerally what this feels like. And this feels like something's going wrong and your sense of vision, everything is just out the window. Like you're just like looking at the world through a different pair of eyes almost. So this is a very visceral thing that you're describing, Zab, about this. Really cool to see it broken down. So we have this model of decision making that roughly speaking is an accumulation of evidence model. It takes a little bit of time for evidence to build up in your brain to decide whether we're talking about a single neuron to fire or not fire based on thresholds and action potentials, which is maybe the first time we said action potential in the podcast. Or we're talking about a more global perspective where we're accumulating evidence and deciding if it's a class A or class B sort of situation. We're adding stress to the equation by dipping our hand in ice water or looking at a picture of a saber-toothed tiger or a snake or something. Okay, so there's these hardware changes that like eyes dilate. And what else? What else happens? Are there software changes too, or is it mostly sort of like hardwired stuff?
I mean, that's a really good question and one that I don't think that we have all the answers to. Because again, like most of this work has been done, we look at these very transient changes that happen in regular people, and stress is, it's complicated in and of itself. And the accumulation of stress is really, it's very, and what people sense, what people can actually self-reflect on with their level of stress, we also know doesn't necessarily completely correlate with the neural activity, the signatures of neural stress. Some people that, report not being stressed, their brain activity is sort of on fire stress-wise and vice versa. And it's hard to know what's the true sense, what is going to be the most predictive of someone being able to still work out what they need to in those different circumstances. We don't yet have enough data to know. That's where that's at, but we're getting closer because we can manipulate and we can start to see, in contexts of real decision making and in real stress, what's actually happening at both brain level, but also the behavioral response.
Let's see. So we're interested in this, I think, for two subtly different classes of reasons. One, because it's just freaking cool and it's how our brains work and it's amazing. And like, who doesn't want to know more about like why they think things they think and how their brain and body interacts with the universe? And two, because there are types of things that are not necessarily moving dots across the background, but really important decisions that we need to make where we face the real boundary of speed accuracy trade-offs and where, lives or success or failures of project operations really come into play. And so we want to understand this to get better at seeing essentially blind spots, things where having trouble making decisions and how to build scaffolds and support structures around me to optimize my ability to harness the software and the hardware and best decisions as possible. Moving slightly from this basic model into this other space that I'm describing, where we want to operate more sort of thing. What is that looking like now? I mean, can you share some of the details of some more real life studies we're doing, or is it worth talking about like we learned just by observation, or what's the next step?
Yeah, that's a great question. I mean, one of the areas that we're thinking about using some of this and its relation is being able to use more simple biometrics to predict stress resilience in people that are going to have to do really high stakes work. This is, emergency medicine, trauma, surgery, special military, all of the above, right? Even to the idea, could we offer some tools to help people understand where they lie on a susceptibility to stress axis? This is something in medicine that I didn't go to medical school. I went to graduate school instead. But I, for sure, have taught many people who have gone on to become doctors and surgeons. And I also know a lot about medical school processes, being part of a school of medicine for many years. And, we think about knowledge and framework and learning for doctors, but we don't really, as you know, equip them necessarily with an understanding of where they are, both starting out and then as they accumulate their own expertise. And there's some really intriguing new studies that have come out in the last couple of years that suggest that we may actually be able to measure, for example, pupil dilation under very simple cognitive tasks that can be done in a well-controlled laboratory. That then, could be reinforced by deeper brain imaging technologies, but something that like ideally the model would use something that could be, more scalable and less expensive than brain imaging. But if you really wanted to be sure, you would probably put all these things together. And our colleagues who did some of this work, are at Zurich, Birgit Klein and Christian Ruff were really behind this particular study, where they use pupillometry and brain imaging of locus coeruleus. So that's in the brainstem. It's part of the arousal system, just like the pupil is, as we talked about. And then went on to see that certain people were predicted to be more stress resilient when they became medical fellows. We have to be careful ethically, right, with the predictive algorithm. This is what everybody is talking about right now is, the role of AI and predictive algorithm, ethical algorithms, in predicting what you should or shouldn't do. But wouldn't it be great if you knew ahead of time before you, became an emergency medicine physician that you might have a harder time with the stress resilience? And then instead of forcing you out, maybe there is a different level of training and educational process that you would go under if you wanted to. So that's one of the things that we've been thinking about.
That's so interesting. I mean, I think it's a common thread among all of the different teams we work with that folks that perform in these environments are made and not born. Nobody comes out. There's one of the rules of you can't born a special forces person, made a special forces person. Nobody that I have ever met, and having delivered several babies over the years, I have not seen a single baby that comes out as a complete ER doctor at that time. And certainly there's predispositions one way or another. And it's probably really useful to know some of that. And I love this idea of, can we do better at measuring strengths and areas for improvement and arm you with a profile of things that would allow you to get the right learning put together. I don't know of anybody that's doing that. I think it'd be super fascinating to see. And just to back translate this for one, because we talked about pupillometry once before on the podcast in the episode of Adam Schlemsky, which I don't remember which number that was off the top of my head, but it's basically your rough speak here. You're putting a camera on the eye and you're measuring the dilation of the pupil under various circumstances. And we know that the more dilated the pupil is, and this is again a rough sentence, the higher level of cognitive load you're carrying and or the higher level of stress you're carrying. It's a little bit of a mixed picture. That could be intrinsic versus extraneous levels of cognitive load, depending on how you want to break that down. But really, the harder your brain is working in one sense or another. And so you can measure this pupil size and and run people through different tasks in life or in sim life and get a sense of how hard they're working, how much they're responding to. And so you can imagine a scenario where we're doing this and sort of getting feedback on how our team members are doing and asking really interesting questions like, geez, everything seemed great until the backup plan kicked in. And then, wow, everybody's, metrics went off the chart. What does that tell us? Do we need to train the backup plan more? Do we need to train the pivot more? All sorts of really cool, really rich stuff like that, which we don't have yet, but maybe we will. I think is the punchline of that something.
Yeah, that's right. I mean, pupillometry is really easily captured. It just takes a regular camera. The only trick is that, of course, light also dilates or constricts the pupil. Light level changes do. So unfortunately, it's not like we could all just be wearing eye tracking glasses or glasses that have these embedded cameras, in the 3D printed frames and, go about our day-to-day things, and people could just use it as like a real-time indicator of stress or, cognitive load in a particular task. Because again, the real world is pretty messy. And because of that, there's like lots of light changes that happen at the same time. So, which is one of the beautiful things about this particular study is that what you could do is just use a very, simple 30-minute task for people as they're embarking on their career path choices, and where those light levels can be controlled and the technology, can be as fancy or not as you want them to be. And then you can see how that fares. And it's much, much more reliable than any self-report measures that are out there about how resilient people think that they are going to be in the face of acute and chronic stress.
It was so fascinating to me. You said earlier that there are neural stress signals or signals of neural stress levels that are sometimes divergent from, even completely off from, feelings of stress or sort of subjective senses of how much pressure and stress you're under, which raises the possibility that you can be somewhat, I don't want to say compromised, but that your ability to decide can be affected and you cannot be aware of it. Is that right?
That's correct. I think we're just at, this incredible threshold of understanding what we do and don't have access to in the brain, right? So we like to think that we have access and can be self-reflective of all of what goes on in our brains. But we know that's not true, right? We know that, parasympathetic responses, are like this idea that, the other stuff, is the stuff that just keeps us breathing. We don't have to think about that. But then when we do, we realize, like when we think about our breathing, we realize that changes cognition as well. And then we know that there are all aspects of how we problem solve, even how we decide, that aren't at the level of conscious awareness, perhaps on purpose, actually, by our brain circuitry. And yet we can make a really rational, we can say that we have access to something, but we don't necessarily.
That's a point that, like, the difference between what you think you're doing and what you're actually capable of doing is frequently made so painfully obvious in some of these scenarios. I have this memory of not too long ago running a cardiac arrest case, and it was a very unexpected one. We sort of turned the corner and found somebody on the ground in cardiac arrest. And, so we're running it without any sort of setup. We're getting to the point where it's time to shock the person. And I'm looking at instrument panel, and it couldn't be more clear. 1, 2, 3. And 3 is a giant red blinking circle. That's the shock button. And I'm looking at this going, where do I press the shock? Where do I put, I just cannot see this giant red blinking light in the middle of it, despite training people how to do that, teaching people how to do that, and everything else. And you get this space where you're overloaded and things just go different than what you're used to. And if you don't spend time in that world, it's hard to explain how it could possibly happen, right? You can be listening to this like, Dan, how can you now see a giant red blinking circle in the middle of the thing? But it's actually so easy. And this gap between what I think I understand about myself and what I actually do understand about myself is like humbling or awesome, I guess, depending on what day it is, what context we're talking about. So I love that we're maybe making some journeys into that unknown space. It's super cool.
Yeah. I think it's cool too. I mean, I think we have a lot to learn, right? And we don't yet know, on the one hand, what might be very powerful, but what we are aware of and how we think and reflect on what we know versus what other, measures sort of underneath the hood, as it were, like looking at your brain activity itself or a proxy of that through some biometrics. What I would hope is that those things are going to come together, right? And we're going to get much clearer predictions, much clearer sort of use case scenarios for all these different aspects that will fundamentally help us become better at what we do, become part of a toolkit, not something scary, not something, necessarily invasive. But I think, we will have to make decisions about who has access to it, how it's done, who owns the data, all of those things. For sure, the regulation and the ethics are going to be interesting, be a part of as it unfolds. And I think we should be in conversation with one another about that. But I also think it's going to be incredibly illuminating and really is going to be the next step to figuring out how we can really optimize who we are, what we do, and make us healthier.
We've wandered into the deep, dark forest here a little bit in terms of what we understand about the brain. And I'm wondering, can we pull back for a second? So if I'm somebody listening to this and I'm somebody who operates in some of these worlds, what do I do with all of this information? Other than be really hopeful for the future, then I'll have more tools sort of, around the corner that aren't quite here yet. What do I do with this knowledge?
I always coach teams that are making really high stakes decisions, especially from information that they can see, thinking about the speed accuracy trade-off. I like to ask people to step back and say, of those 300 seconds that you have to make a decision, you're talking about the split second. There's almost always time for an extra breath, right? And there's a moment where you might be able to accumulate more evidence, either from those around you on your team or from yourself and from the information that you have on hand before making the last decision. That's one thing that I always like to point out is that we think of really fast decisions, but a lot of times we make those faster than we really ought to, even in these contexts where we have to do things very quickly. And even just being aware, I think, of thinking about what it really means to take that pause can be really transformative. That's one thing that I advocate for, using this sort of knowledge about this decision-making framework. And also to remind people that, when accuracy is really important, to remember that getting more information is going to be helpful as long as the time constraint is still going to work, right? That's one tip that I like to tell people.
Recently, I was working with a bunch of leaders, players and coaches from the professional rugby team, and we were talking about the difference between going heads down and heads up. Heads down, they're doing a skill, they're sort of executing on this one thing, they're hyper-focused. Heads up, they're scanning the field, integrating information, and figuring out what the next play should be. And we were talking about how being heads up all the time isn't the right answer. Being heads down all the time isn't the right answer, but really it's a mix, and that mix is dependent on the task and the situation. And that what marks a more experienced player or junior player part is the ability to get that mix right. And it strikes me that that's very similar to what you're saying in this, and felt this in myself as I've grown as a provider, and I've watched other doctors as they're sort of coming up, is that more junior folks want to make decisions faster because they are more focused on getting out of the situation. It's uncomfortable, it's stressful, they don't know the answer. Our brains don't like that, roughly speaking. We're happier making a decision and jumping onto something. And the more experienced folks will tolerate that discomfort longer while still feeling the boundary of when to make a decision. They're more tuned into exactly how much time there is to make that decision. I have no idea if that observation is held up for me across multiple people and multiple teams. Do you see a similar thing to that? Does experience play a role in knowing that trade-off? Sometimes it interferes, like I said, because you end up with sort of standard operating procedures or preferences in how you deliver something, right? Or how you would normally make a decision. In certain contexts, that can be really detrimental. And the other, context that I would play devil's advocate here for is that, heads up and heads down, I think is a really great, that's a great metaphor for thinking about that. But that's also just an individual,
now we have much more complicated real worlds where there are teams and people interfacing with one another and that often have to do very significant things in action and teamwork together. And it becomes a lot less constrained when your accumulation of evidence could also come from those around you and your willingness, right, to take in that information from those around you and value and think their evidence might be able to help you or pull you away from your own standard operating procedure and bias point when it might be helpful and when that might actually be unhelpful is much more murky, right? So with experience, we strengthen some of our biases and our knowledge, and we do become experts, but we have to be careful also about what that means, both when we're working on our own and when we're working in team.
Yeah, I'm thinking as you're describing this of a study that I heard from Gary Klein. I actually don't know if he and his team did this or if this is just where I first heard of it, but they basically presented patterns of chess players to novices and chess masters and were looking at basically how quickly they could capture the information contained in them. And when they provided real chess positions, the chess masters were way off the charts compared to the beginners. When they provided random pieces on the board, everything slowed down and people were roughly equal, right? The punchline in that sense being our expertise is limited to the areas in which we are experts, which is very circular and confusing because we don't always know where we're experts or if this thing we're facing it's rarely presented to us as cleanly as here's a chess puzzle, go solve it. It takes this unknown shape and I have to decide how much of I probably don't. I don't know. Maybe I decide, maybe I just sort of pops out how much of my expertise and thinking is actually applying to this. We're just getting murkier and murkier. It's a harder and harder problem to solve.
It is. So, and the other thing that I think that I really like to help people understand is actually that piece of like what you can gain from others around you. And so sometimes that's called perspective taking in evidence from others and building your own mental model of whether to put that in or to discredit it, right? But I think that exercise of just having to do that can be really illuminating for teams and for individuals as well. That's another area that I think people that work in really stressful contexts should actually learn, because it turns out that all of our knowledge and framework and experience and expertise is quite different from one another, even if we all do the same thing. And so when you allow for some room to take in information from other people, it can often be some of the most productive time, which is one of the reasons why I think stumbling upon your colleague and having a conversation can sometimes lead to, the best breakthroughs, something that we can't simulate when we just have planned meetings with one another. This idea of how you take in information from other people around you is really critical. It's especially critical in sort of advanced work where we rely on experts all around us.
We're coming to the end of our time here, and I want to give you a chance to challenge everybody listening to this. So for folks that are going to come away from this and operate in whatever sort of a team or environment they're going to be in over the next little bit, what would you want them to do differently? What do you want them to try or explore?
I would ask people to think a little bit about a common routine task that they do and how fast they are at, maybe discriminating between two options when faced with that, and whether there's any way to tell other people about how you can learn that in a process where what you don't do is put the bias point all the way at your threshold. How can you begin to develop the next group of people that will need to learn those same skills? So deconstruct your own process, but then also think about it from a learning context. How could you accumulate evidence faster over time without just pushing it into the bias zone? Really, I think that that's just an incredibly useful way to think through, both learning and development of the next generation, all the people that you're trying to bring up, but also for yourself to realize that some of those things might be detrimental to the way that you are also just making your own decisions every day.
Thank you so much for coming on the podcast and sharing your expertise and enlightening all of us with this. I deeply appreciate it.
It's been my pleasure, Dan.
All right, folks, that brings us to the end of this episode. I hope you learned something and I hope you enjoyed. As always on this podcast, our goal is to dive deep into what it takes to perform under pressure. Nothing that we discuss here should be construed as medical advice, and all of the opinions that we discuss are our own and are not necessarily representative of any organization with which we were affiliated or for whom we work. If you want to go even deeper and get more involved, don't forget to check out our book. It's called The Emergency Mind: Wiring Your Brain for Performance Under Pressure, and you can find it at emergencymind.com/book. All right, good luck out there.